Hello everyone. In this video we're going to have a brief introduction to data structures. But before we dive in, let me introduce you to my Learning Data Structures and Algorithms course. It's completely free and it will stay that way forever. So don't wait any rule now to learn more. You will find a link to the course in the video description below. So first of all, let's start by explaining what's a data structure. If we want to reverse engineer the phrase data structure, we can see that it's composed of two main words, which are data and structure. Data refers to a set of items and structure is just the arrangement of something. So if we combine the two definitions, we will have something like data structure is just an arrangement of a set of items. In the context of computer science, data structure is a way of arranging data in a specialized format and a computer memory, so that it can be efficiently managed, which means efficiently stored, processed and retrieved. Now let's move on to talk about the classification of data structure. Despite the choice of programming language, data structures can be categorized into or in many different ways, though generally they can be classified as linear or non-linear data structures as shown in the diagram. A data structure is said to be linear if the data is arranged in a straight sequential order, one after the other. A good example of that would be arrays, stack, queues, and linked lists. On the other hand, we have non-linear data structures when the data is arranged in a non-sequential order or in a hierarchical manner instead. For example, we have graphs and trees in this classification. Now let's talk about basic operations on data structure. Here is a list of the most common basic operations that are used for data management in data structure. First we have selecting, which refers to accessing a particular item within a data structure. Then traversing, which refers to visiting each item within a data structure at least once. We have also inserting, which is adding a new item to a data structure. We have deleting, which is removing an item from a data structure. Then we have searching, which is finding a specific item within a data structure that satisfies one or more conditions. Then we have sorting, which refers to arranging the item within a data structure in a specific logical order. And finally, we have merging, which refers to combining two data structures into a single one. Now let's move on to talk about how to choose the right data structure. Choosing the right data structure to solve a particular problem would depend on many factors. You should take into consideration the frequency in which operations are performed, since it's going to help you quantify the resource constraints, mainly time and memory, which leads us to talk about the two other factors, which are time complexity and space complexity. So same operations have different time execution in different data structures. Therefore, if you think that time execution is crucial for your problem or for your situation, then you need to pick the right data structure for that. Same goes for space complexity, but this time it deals with memory allocation. So in this case, you have to pick the right data structure that is going to guarantee somehow an efficient memory allocation. Time complexity and space complexity are often expressed theoretically in big O notation. So don't worry if you don't know what's that right now, because it's going to be the topic of the next lesson in this series. Finally, let's talk about the last point in this video. Why do we need data structures in the first place? We can sum up the need of data structure or for data structures in two main points, which are efficiency and abstraction. For efficiency, we have already mentioned and discussed that choosing the right data structures to solve a problem helps us to increase the efficiency of our solution. Therefore, data is processed in the most appropriate and efficient way possible. For the second point, which is abstraction, through the use of data structure, we ensure a high level of readability and simplicity. And this is done by hiding the low-level details of the associated operations. The only thing that a data structure provides is an interface to manipulate the data. That's all for today's video. Hope you've learned something new today. Don't forget to like, comment, share and subscribe to my channel. Thank you for watching and see you soon.